Here is our second question based on differentiation from first principles, calculus grade 12. We are given f of x is equal to x squared plus x. We know that the first step is for us to determine f of x plus h. So in the given equation, wherever you have x, you are going to replace it with x plus h. So we had an x squared, here we have x plus h squared, and then plus x, so we replace that, it becomes plus x plus h. We now need to simplify. We've got a binomial squared, which is going to result in a trinomial. The trinomial that you get is x squared plus 2xh plus h squared. Not forgetting about the next two terms, which is plus x and plus h. Now always check if you have like terms, if you can gather like terms. In this case, we cannot. There is nothing common. So we're going to leave this as is. Next, we are going to write down our formula. So for first principles, f prime x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. As I've mentioned in the previous video, your formula for first principles will be given to you on your formula sheet. Now let's substitute. We have the limit as h approaches 0. For f of x plus h, remember we just got that above, so let's write down all of those terms. Minus. Now f of x is given to you. So from the given info, f of x was x squared plus x. We're going to substitute that into a bracket only because of the minus in front. Don't forget your denominator here is h. In the next step, we're now going to take that negative that's in front of the bracket and multiply it into the bracket with both terms. So all the terms before the bracket would stay as is. Multiplying the negative into the bracket becomes negative x squared minus x, and our denominator is h. At this point, we realize that we've got x squared minus x squared. We have plus x and minus x. So those terms cancel out with each other. Now, from the remaining terms, which you have 2xh plus h squared plus h, you notice that all three remaining terms contain h. We can pull out h as a common factor, and what we're left with is 2x plus h plus 1 all over h. Now what happens to the h that you pull out as a common factor? That h cancels out with the h from the denominator. At this point, if there are any terms left that still contain h, that is where we make use of the limit. So we're now going to take this limit. Remember, h is approaching 0. So we now take this limit and we substitute in place of 0. Sorry, in place of h. So where we have h, we're going to say plus 0, and then there's a plus 1. Now, generally it's good for you to show your substitution. So you're showing the marker that, hey, this is what happened with the limit. I made use of the limit. So we show the substitution and then we simplify. So we are left with 2x plus 1 as our derivative. So there we have it. We have differentiated from first principles. Please remember to like, subscribe, and turn on your notifications for more content.